Okay, today you are going to learn how to solve radical equation. To begin with, it's good to know why we do this. So when you're solving an equation, this question is, what is the inverse operation of each of the following? So for example, if you have 2x minus 3 equals 7. This is well, let's do 2x plus 3. This is an addition problem. 2x plus 3. How do I get rid of the plus 3? By subtracting. Okay? So the inverse of addition is subtraction. So along those lines, hopefully you can fill in the rest. So that's what I need you to do. So multiplication, what's the inverse of that? I guess that one was supposed to be dividing. What's the inverse of dividing? And what's the inverse of squaring? The inverse of squaring is square rooting. So for example, if you have x squared equals 16, just take the square root of both sides. These cancel themselves out, and you're just left with x equals plus or minus 4. Square root is what we're doing today. So the inverse of square root goes along with squaring. You know, it's the same thing. It's just the opposite of it, the inverse. So for example, the square root of x equals 4. If we square both sides, I guess I should put it over there, you get x equals 16. Okay? So that means if you put a 16 in for x, the square root of 16 is 4. Which makes complete sense when you think about it. But that's how that works. Okay. The steps, I believe you have the steps on your paper. So these are the basic steps. Please refer back to them throughout the video. You're isolating the radical, you get it by itself. So write that down. If you don't like the word isolate, write down get by itself. Square both sides. So you may have to do some foiling, but some basic squaring. Solve the equation, and then finally check the solution. It's a full check that you need for this problem. Okay, the first example is the square root of 2x minus 3 equals 5. First thing you have to ask yourself, is the radical by itself? Is it isolated? So draw a line here. Is there anything on this side of the equal sign besides the radical? No. So that's good. We're done with that. Step 1. Then we have to square both sides. When you square this side and this side, if you remember from the past, anytime you square, this is just an aside here, anytime you square a radical, so we square this, we get radical 49, or 7. If you square anything, 5 squared, radical 25, which is 5. You always get what's underneath the radical. So these cancel themselves out in the most basic sense. So then you're just left 2x minus 3. This one, you're not so lucky. You actually have to do the math. So that's 25. Now we just simply solve the equation. And x is 14. Finally, you do have to check in the original. So the square root of 2x minus 3 equals 5. Put the 14 in for x. This is basic. You could just put this in your calculator. But 28 minus 3 is 25. So 5 equals 5, and that one works. So that's it. That's the basic idea. You want to get rid of the radical, so you get it by itself and square it, getting rid of it, and then solving. Okay, this one. First step. Is the radical by itself? So look, Draw a line here. On this side of the equal sign, is there more than just a radical? Yes, there is a 4. So we need to get rid of the 4, so you use its inverse operation. 4 is positive, so you subtract 4 from both sides, and you get the square root of 1 minus 3x equals 8. Okay, now is it by itself? Draw the line. Yep, on this side of the equal sign, there's only the radical. So now we square both sides. This side is nice. The radical just goes away. But this side you actually have to square. So now you solve it. Subtract the 1. Oh, there goes my dog. Divide by -3. And x is what? -21. That's great. I have to go to the other side. Okay, so now we have to check. Always in the original. Take that -21 and plug it in. Doing this math, it's 4 plus, that is 1. You should have a calculator, but this is positive 1 plus, well, I just did that over here, right? 63. So we're not sure if these are checked yet. So it's 4 plus, this is radical 64, so that's 8. So that's 12 equals 12. That's a check. Okay, next one. The baby's waking up. Okay, this one. Alrighty. First question, ask yourself, is the radical by itself? Draw a line down the middle. Okay, okay, let's focus. There we go. We're back. Stay. Okay, so the 1 is on this side of the equal sign with the radical. So we need to get rid of it. So this is a positive 1, so we subtract 1. And you know what happens when you add these two, and you do it for real, Asparis freaks out on you. So x minus 1 is x minus 1. Thank you. Can't do anything with that. So it's 15 minus 7x. So now the radical is all by itself. So now this problem just got fun. Square both sides. I know some of you don't like the radical on this side. If you feel the need, you can flip it to the other side, but it doesn't make much of a difference. This cancels this out, so you're just left with 15 minus 7x. But this side, this is where all the fun happens. All the fun. X minus 1 squared. Let's do this. Is x minus 1 times x minus 1. So you got to do the F word. You got the FOIL. So x times x, do this whole mess. So it's x squared minus 1x plus 1 is equal to this side. So what happens when we did this is this x squared happened. Anytime you have an x squared term, he's the king. Everything goes to his side. I'm going to combine like terms first before I move things over. Just because I'm gonna. Okay, so now this one moves over. This one moves over. I'm going to put them under their like term. So if you're happy and you know what you can factor, I hope. So it's minus 15. 15, that looks terrible. Okay, and then you factor x plus 7, x minus 2, T-chart, x equals -7, x equals 2. Okay, so the check is a little bit more trying. You need to check both answers to see if both of them work. So here's the original. So first one we'll try is -7. I don't feel this working, but that's just me. I don't know how we could get this equal to a negative, but that's just me. You never know. So this is 49 plus 15. $64. So that's 8. 1 plus 8, -7 equals 9. It does not. It's not always the negative one that gets rejected. So please make sure you keep track of that and check them all. And then you have to check. So I wrote reject right there. And then I try this one. I use the same equation. Now I'm just plugging in the 2. So 2 equals 1 plus 15 minus 7 times 2. So I do the math. 1 plus radical. So that's 15 minus 14. So that's 2 equals 1 plus 1. That checks. So that one's good. That's the answer. So always check and take it from there. Okay, this is a doozy. It looks like a doozy, but it really isn't. It's not bad. So you just have to ask yourself, is the radical isolated? There's 2 of them, but they're isolated. They're all by themselves. So let's just go right ahead and square both sides. When I square both sides, the radical and the squaring cancel themselves out. And we're just left with 5x plus 2 equals 9x minus 14. Solve. Move the number with the variable. Okay, and solve. You are not here to tell me if I'm doing this right. Sometimes I make mistakes. So this is 16 equals 4x. My daughter is singing in the background. So x is 4. And we check. Okay, finally we have to check this solution. And we simply plug 4 in for x. So it's 5 times 4 into this the original, plus 2 equals the square root of 9 times 4 minus 14. This is 5 times 4 is 20, plus 2 is 22. Does that equal 9 times 4 is 36, minus 14 is 22. Radical 22 equals radical 22. Check. Therefore, x equals 4 is the solution. Okay, that's it. Try the last one on your own. It is similar to the last one that we did. Right here. Try it out and enjoy yourself. Goodbye.